In GCSE, if we wanted to work out the arc length or the area of a sector, we had to use some quite awkward formulae. For the arc length, we worked out the circumference of a whole circle, which was either pi times the diameter or 2 times pi times the radius. So that was the circumference of a whole circle, and then we times it by the fraction of the circle that we had, which was the angle out of 360. That was our calculation for working out the arc length. And similarly, if I wanted to work out the area of a sector, I would do the area of a whole circle, so pi times the radius squared, and then again times it by the fraction of the circle that we have, which is theta out of 360. Now, these are quite cumbersome formulae, and the reason why they're cumbersome formulae is because of the fact that 360 degrees in a circle is an artificial construct. Remember from the last video that we said that there's 360 degrees in a circle only because we can split 360 degrees into lots of different factors, which just makes our life easier. We've now got a much better unit for measuring angles in, which is the radian. Remember from the previous video that we know that pi radians is 180 degrees. So 360 degrees is 2 pi radians. The reason why the radian unit is much better than the degrees unit is because it is dependent on the radius of the circle. Remember, 1 radian is the angle that produces an arc length that is equal to the radius. And so, because it depends on the actual natural property of the circle, we're going to see some nice simplifications in these formulae now. Because rather than the 360 degrees here, if I instead use 2 pi radians, what we see in the formula is actually the 2 pi here and the 2 pi here cancel each other out, and we get left with a much, much simpler formula where the arc length is equal to the radius times the angle. Similarly, with the area of the sector, if I replace this 360 degrees with 2 pi radians, again we see that the pi is going to cancel out. We've still got the 1/2 there, but that's okay. We've got the 1/2 times the radius squared times the theta. And so, if we are in radians, we have much simpler formulae for the arc length and the area of a sector. So these are the two formulae we are going to be using to work out the arc length of a sector and the area of a sector. It's important to note that these formulae only work if that angle is in radians. You cannot use these formulae if you are in degrees. If you're in degrees, you need to use those awkward GCSE formulae, or convert to radians first and then use these formulae. So let's have a look at a couple of examples. So here we need to find the length of the arc of a circle that's got a radius 5.2 centimetres, given that the arc subtends, so that just means creates, an angle of 0.8 radians at the centre of the circle. So let me draw this out so we can picture what's going on. We've got a circle that's got a radius of 5.2. And the arc is subtending, is creating an angle of 0.8 radians. So I'm going to mark on 0.8 radians here. And this is the arc here that's subtending that 0.8 radians at the centre of the circle. So to work out that length, we're going to use the formula the arc length is equal to the radius times the angle. The radius is 5.2, the angle is 0.8. So 5.2 times 0.8 is 4.16 centimetres. And so that is the length of that arc length. That's the length of that arc. Second example, it's a more complicated one here. We have got the diagram showing a logo that's consisting of the triangle ABC and the sector BCD, where ABD is a straight line. We need to find the perimeter of the logo and the area of the logo. So, considering that I know all of the sides of the triangle here, I can work out this angle here relatively easily using the cosine rule. I can say cos theta is going to be equal to 10 squared plus 8 squared minus the 9 squared divided by the 2 times the b times the c, so the 2 times the 8 times the 10. I'm going to put that into my calculator, and then I'm going to do cos inverse of that. Now it's important to make sure your calculator is in radians mode for this question, so that we're able to use those nice formulae we just saw a minute ago. If we're not in radians mode, then those formulae, then your calculator will give you this answer in degrees, which will then mean those formulae won't work. So make sure your calculator is in radian mode. Go back and watch the last video if you need a reminder of how to do that. So, I work out that that angle theta is 1.0254 radians. Now I can now use that to work out this angle, because I've been told that ABD is a straight line. So I know that these two angles will add up to be pi radians. 180 degrees, but pi radians. So if I now do pi, take away the 1.0254, I work out that that blue angle here is 2.11618. I'm using lots of decimal places here because I want to make sure my answers are as accurate as possible. Now, with that information, I can now work out the arc length here. So I know that the arc length is going to be equal to the radius times the angle. The radius of that sector is 8. If this is 8 and it's a sector, then this is going to be 8 as well. So the radius 8 times the angle 2.11618. So that arc length is 16.929 centimetres. I can now use that to work out the perimeter of the logo, which is going to be all of the different lengths around the outside of this shape added together. So I've got the 10 plus the 8 plus the arc length that I've just worked out, which is all of that, plus the 9. So 10 plus 8 plus 16.929 plus 9. And we find that the perimeter of this logo is 43.9 centimetres to one decimal place. So that's part A of the question answered. For part B, we want the area of the logo. So for the area, I'm going to see the area of the triangle plus the area of the sector. The area of the sector, I can use the nice formula that we just saw, a half r squared theta. So a half times 8 squared times the angle, which is the 2.11618. which gives me an area of 67.7179. So that's the area of the sector, that's the area of all of this. I then need to add the area of the triangle to that. Well, for the area of a triangle, I can use the formula a half AB sine C, where A and B are the two sides either side of the angle that I'm going to use. So we'll do a half times the 10 times the 8 times sine of the 1.0254, which gives me an area of 34.1698. So therefore the area of the whole logo is the sector plus the triangle which to one decimal place gives me 101.9 centimetres squared, and that's my answer to part B of the question. So, as long as you're in radians, which we do want to be for a lot of this work, because it makes our life much easier, then you can use these formulae for the arc length and the area of a sector.